So now we'll move into how to calculate the molar mass of any compound that you may deal with. This being either ionic compound, molecular compound, hydrocarbon compound, whatever compound that you have. So is how to calculate the molar mass of any compound. It is a very important skill that you need to know. You will be facing this even on the first unit. Now, this information is gathered from the periodic table. Remember what we said in periodic table, that you have in each box, you have an information. You have the atomic number, which is telling us what is the number of protons in the nucleus and the place of the element in the periodic table. But then you have another important number, which is in decimals. If the atomic number is whole number, this is in decimals. And this is the atomic mass. So this is the information that we will use to calculate the molar mass of any compound. We'll start with an easy one. Let's suppose that we have a hydrogen. So hydrogen molecule is always H2, along with oxygen that is always O2. That means that you have two atoms of hydrogen. How do you know that you have two atoms of hydrogen? It's this little number here that tells you that you have two atoms of hydrogen. This is what that number indicates. Therefore, if you are calculating the molar mass of hydrogen, then you will say that, oh, I have on this molecule, I have two atoms of hydrogen. Then I will go to the periodic table, find where hydrogen is, and look for the atomic mass of hydrogen, which is 1.01 grams per mole. Okay, those are the units, grams per mole. And multiply that by the number of atoms that I have in the compound. And when I multiply those two together, I have 2.02 grams per mole. Okay? What does that number mean? I always say to my students, when I have a number in science, a number is just a number. And you will see me that very often I'm like, whatever is this number? Because that number has a meaning. Okay, what this number means that when you have 2.02 grams of hydrogen molecule, then you have 1 mole of hydrogen molecule. Okay, and vice versa. If you have 1 mole of hydrogen molecule, then means that you have 2.02 grams of hydrogen accumulated there. And remember what 1 mole is from? It is 6.02 times 10 to the power of 23 atoms or molecules of the thing. Okay, Avogadro's number. Okay, so then when we are dealing with just, let's say, nickel, okay, nickel. The formula for nickel is just an I. That means that we have 1 atom in this molecule. Okay, that means that we have 1 atom of nickel on this molecule. Therefore, to calculate the molar mass, we will go, what is the atomic mass of nickel? We'll go to the periodic table. We'll refer to the number that is in decimals, 58.69 grams per mole times the number of atoms that we have, which is 1. That means that we will have 58.69 grams per mole as the molar mass of nickel. Now let's see a more difficult situation. Let's suppose that we have nitrogen dioxide, okay? So let's suppose that we have nitrogen dioxide, so NO2, which is a molecular compound. You know, if you put your fingers to nitrogen and oxygen, they are close to each other, means that they are sharing pairs of electrons. Another thing is when we are saying it is nitrogen dioxide. So we are using the molecular way of the IUPAC rules. That means that we have one nitrogen and we have two oxygen. How do we know that we have one nitrogen? Because this number here is 1, which we do not write, and this number here is 2, which we identify. So that tells us that we have one nitrogen and two oxygen. Then what we do is to calculate the molar mass is we go to the periodic table. So we find nitrogen. The atomic mass of nitrogen is one nitrogen that we have. So one nitrogen that we have here. Atomic mass is 14.01 grams per mole plus the and sign. 2 oxygen that we have times the atomic mass of oxygen is 16.00. And then I think that I had a calculator here. 46.01 grams per mole, which means that when you have 46.01 grams of nitrogen dioxide, you have 1 mole of nitrogen dioxide. And if you have 1 mole of nitrogen dioxide, then you have 46.01 grams of nitrogen right now. So let's suppose that we are calculating the molar mass of CuNO3 2. Okay, so let's identify first what is the number of elements on each of those what is the number of atoms on this compound. So we have 1 copper, okay, and then you see a 2 here, and since the brackets are, that means that this 2 is multiplying whatever is inside the brackets. So we'll have 2 nitrogen, okay, and then we keep going. Inside the brackets, we have 3 oxygen, which is multiplied by 2. 3 times 2 is 6. So just for the sake of you having it there, I will write it as 2, that is below, and then times 3 times oxygen, the number of oxygen. As soon as you identify the number of atoms in the compound, and this is probably the hardest case that you will see, then you move to the periodic table and then you say, what is the atomic mass of copper? And then you have 1 copper times 63.55 plus 2 nitrogen, and then you go to nitrogen, which is 14.01, and then 2 times 3 is 6. You can leave it as 2 times 3. It's fine. 6 times 16.00. And then enter it in your calculator as you see it here. And that will be the molar mass of copper nitrate. So it is 187.57 grams per mole. Which again, what it means is that if you have 1 mole of copper nitrate, then you have 187.57 grams of copper nitrate. Let's suppose that we have an organic compound, which we will deal with it when the unit comes. But for now is 1 butanol, which is 1 we will deal with it later on, but it is the chemical formula for it is C4H9OH. Okay. Now, when you see this, then the very first step, as I said, is identify the number of atoms in each of the number of each atom in the compound. So you have 4 carbon, and then you have 9 hydrogen, and then you have 1 oxygen, and then you have 1 hydrogen. You can combine the 9 and 1, but it will be the same thing if you are doing just what I'm doing. So do not even try to do more when you have as the first step identify the number of each atom in the compound using the suffixes here, 1 1. So it don't complicate your life. Then we have 4, that is the number of carbons, times 12.01 grams per mole, plus 9, that is the number of hydrogen, times 1.01, plus 1, that is the number of oxygen, times 16.00. And I know that mathematically the 16.00 doesn't make any difference if you're typing 16 or 16.00. However, in chemistry, what you are indicating is that this is the accuracy that you are using with, and I would prefer to have that 0.00 there, even though that it is mathematically it's not important. And then you enter it in your calculator as you see it here. I have 74.14 grams per mole, which means that you are dealing with 74.14 grams of 1 butanol if you have 1 mole of butanol, or if you have 1 mole, then you have 74.14 grams.